Nuclear power. What's the first thing that comes to mind when you hear those words? Did you feel a chill go down your spine? Well, you're not the only one. While nuclear power has had quite a controversial history in human hands, did you know that it's also the same energy that powers the sun and the stars? More specifically, nuclear fusion could replace non-renewable fossil fuels for good and become the cleanest source of energy there is out there.
Hey, that's pretty good.
Sounds rather far-fetched? Just this January, China's $1 trillion experimental fusion reactor set a new world record of superheating plasma at a temperature 5 times hotter than our sun itself for a little over 17 minutes. Talk about making an artificial sun. So what I'm saying is, if we do manage to put nuclear fusion to good use, we could get an endless supply of clean energy out of it. Now, you might ask, what is this fusion reactor anyways? A fusion reactor is basically a large device, or a power plant per se, that produces electricity by using energy from a nuclear fusion reaction. So what is nuclear fusion then? Scientifically speaking, it's when two very high-speed atoms fuse, or combine with one another, releasing any leftover subatomic particles, or neutrons in particular. And these neutrons are what could make an unlimited supply of electricity. So in layman's terms, a nuclear fusion reaction is a simple two atoms combine kind of reaction, with power so masterful that it fuels the sun and stars of the solar system. Coming back to fusion reactors again, scientists in the 1950s theorized that if we could replicate the nuclear fusion occurring in the sun in a controlled manner, we'd be able to develop an inexhaustible source of energy, and then started a wave of tireless efforts to crack the code of nuclear fusion all across the world. Unfortunately, sustaining this level of force, speed, and pressure have not been possible for more than 20 minutes as of yet. You need temperatures higher than the sun and force more than twice as much as that needed to send out a space shuttle. The reactor has to be really durable to withstand such abuse. So not an easy task, I must say. But don't give up on fusion just yet, fellows, because these limitations haven't stopped ambitious projects like ITER in southern France from pursuing the true potential of fusion reactors. With the world's largest magnetic fusion reactor in the world, engineers and scientists from 35 nations are attempting to generate carbon-free energy, the same way as the sun does. And this reactor isn't small, by the way. It weighs about 23,000 tons. So, in decades to come, this fusion reactor might become the birthplace of a whole new form of energy. And in fact, a form of energy that most of us fear so far, actually. Don't we? I'm not sure if it can get any more fascinating and mind-blowing than that.